Hello, welcome to Prajim Technologies. I am Venkat. This is part 19, Introduction to Classes. In this session, we will learn what a class is, purpose of a class constructor, overloading class constructors, understanding this keyword and destructors. So what is a class? So far in this video tutorial, we have seen very simple data types like integer, float, double, boolean, etc. Now, if you want to create a complex custom type, then we can make use of classes. What do we mean by a complex custom type? Let's say, for example, if I want to store a number, I can do that using an integer variable. But if I want to store my customer information, then I can make use of classes. Now, what kind of information does a customer has? He has first name, last name, date of birth, email, etc. Now, using the built-in fields, we can create a class, and also not only a customer class, it not only contains data, it can also do certain things like save the customer to the database, print the customer full name. So essentially, a class consists of data represented by its fields and behavior represented by the methods. Okay, so a class has state and behavior. State is nothing but the data. Behavior is nothing but what is the class capable of doing. For example, a, we can save a customer to a database. We can print his full name, etc. Let's look at an example, which will make things clear. Okay, so how do we create a class? To create a class, we use the class keyword followed by the name of the class. So class customer. And all of us know customer will have first name and last name. So let's create them. String first name. Actually, we will use an underscore. String first name. String last name. So these two fields represent the state, the data that this class is having. Okay, the first name and last name. Okay, now to initialize these fields, a class can also have a constructor. So how does a constructor look like? A constructor will have the same name as that of your class. Okay, so public. Public is nothing but the access modifier. We will be talking about access modifiers in a later session in a great detail. So access modifier and then the name of the class, public customer. And what is the purpose of constructors in life? Constructors are basically used to initialize your class fields. Okay, we will later understand in a bit how we use this constructor. Okay, so for now, I am passing two parameters into this constructor: string first name, string last name. Okay, so this is the constructor. It's having the same name as that of your class. Okay, and it can take parameters, but a constructor does not return a value, whereas a method can have a return type. And if your method doesn't return anything, the return type is void. Otherwise, you can have any return type like int, float, double, boolean, etc. But a constructor, the way you can identify this as a constructor is by looking at its name. It will have the same name as that of your class, and it will not have a return type. But a constructor can take parameters. Now, I am actually using this constructor to initialize these two class fields, first name and last name. So I can simply say underscore. So this field is equal to the parameter that we are passing into this constructor. Similarly, underscore last name is equal to the parameter that we are passing into this constructor. Okay, now you can refer to this class field, just by its name, or you can say this dot, and look at this. The moment I say this dot, the IntelliSense shows both the class fields, underscore first name, underscore last name. Okay, so now this keyword actually refers to an instance of this class, to an object of this class. Okay, so you can either say underscore first name, or for better readability you can use this keyword, this dot last name. Okay, so basically we are using this constructor to initialize both of these class fields with these parameters that we are passing into this constructor. And this constructor will get called automatically when we create an instance of this class. We'll have a look at that in a bit. Okay, so far we have two fields and a constructor to initialize those two fields. So our class has some state right now represented by these two fields. Now let's say I want to add some behavior, in the sense the class should be capable of doing something. For example, I want this class to be in a position to print the full name of our customer. Okay, so for that, let's have a function, let's have a method, and the return type of the method is void, public void, and I'm going to call this method print full name. So what is this method going to do? This method is going to print the full name of this customer. Okay, so how do we do that? Console.writeLine full name is equal to underscore first name, have a space in between first name and last name, underscore last name. Again, if you want to refer to this class fields, you can just type in the fields just like this, or for better readability you can use the this keyword. And as we know, this keyword refers to an instance of this class, to an object of this class. Okay, so if you look at our class now, it has got two fields, a constructor and a method. Apart from that, a class can also have destructors, and destructors will have the same name as that of your class, but they don't take parameters, they cannot have return type, and they have a tilde in front of them. Now, usually in C# we don't require destructors. The objects, basically we use destructors to clean up the resources, to clean up any resources your class was holding on to during its lifetime. Okay, so any code to clean up those resources goes in this destructor. And these destructors, we don't have to call them. These destructors are called automatically by the garbage collector, when it kind of tries to clean objects from the memory. We will be talking about destructors and garbage collection in a very great detail in a later session. For now, just understand that a destructor will have the same name as that of your class. It cannot take parameters, and it has a tilde symbol in front of it. And destructors are basically used to clean up any resources that your class was holding on to during its lifetime. And these are automatically called by the garbage collector when it turns up to clean your objects from the memory. Okay, so your cleanup code goes here. And this is your method, which represents the behavior. This is your constructor, basically used to initialize your class fields. Now, if I want to use this class, I can do that in our main method. Okay, so we can go ahead and create an instance of this class, customer C1 is equal to new customer. Now look at this. I am creating C1 is nothing but an instance of this class. So I'm creating an instance of customer class using the new keyword. This instance is also called as object. Object and instance. These terms are used interchangeably. So I'm creating a new customer object. Now look at this. The moment I open up this parenthesis, it shows up our constructor. This constructor, which takes in first name and last name. And let's say, for example, I am passing in the first name as Prajim and the last name as Technologies. So what's going to happen now? This Prajim will be passed into this parameter, Technologies will be passed into this parameter, and these parameters are then used to initialize these two class fields. So understand that this is the constructor which is getting called automatically when we're creating an instance of this customer class. Okay, so what are constructors? Constructors are called automatically when you create an instance of your class. And what is the purpose of this constructor? It is basically used to initialize your class fields. This dot first name, this dot last name will now be initialized to first name to Prajim and last name to technologies. So that makes it clear the definition of constructor. A constructor is called automatically when you create an instance of this class, and the constructor is basically used to initialize those class members. Okay, and then if you want to print the customer full name, you just say c1.print full name. And if you look at this, after we create this object, we are calling the print full name. So now in this customer object, the state, which is the first name and last name fields, are initialized to Prajim and Technologies, and your print full name is actually concatenating them together and writing them out to the console. Okay, so your constructor is ensuring that these fields are populated before we actually use those fields in this method. Okay, so that proves that a constructor is used to initialize your class fields, and it's automatically called when you try to create an instance of your class. Okay, so if we go ahead and run this program, as you might expect, full name is equal to Prajim Technologies. Now, is it mandatory that we have to provide a constructor every time we create a class? Not necessarily. For example, let's comment this constructor, and you can do that by clicking that button. So once I comment that, obviously since we don't have that constructor, it gives an error. There is no if you look at the error, customer does not contain a constructor that takes two arguments. There is no constructor which takes two arguments. So now we can't do that. But what I can do is, look at this. When I say new customer, automatically I'm getting a constructor without any parameters. If you look at this, customer, open parenthesis, close parenthesis, it doesn't take any parameters. So what does that mean? If you do not write a constructor, if you do not provide a constructor for your class, .NET Framework will provide one for you for free. Okay, and it is a default parameterless constructor. Okay, there are no parameters. The default constructor provided by .NET Framework is a parameterless default constructor. Okay, and this default constructor, what it does is basically walks through all the fields in the class and initialize them to their defaults. Now look at this. When I call this default customer, this first name and last name, they are not initialized to anything. Okay, they are basically empty. So now if I go ahead and run this application, look at what's going to happen. Full name is equal to empty. And now somebody is able to use call this method in spite of those fields not being initialized. That's why you have that full name is equal to empty. Okay, so this default parameter less constructor is not really that useful. And if you want to make that a little more useful, what you can do is basically you can provide, let's say I have this constructor. But another thing to keep in mind, look at this. The moment I provide a constructor, I have provided a constructor for my own class, and the moment I have done that, look at what happens to the default parameterless constructor. Customer does not contain a constructor that takes 0 arguments. So what's happening here is that once we provide our own constructor to this class, .NET takes away that default parameter less constructor which it has provided when your class doesn't have any constructor. Okay, so it's taking away that constructor. That's why it says that error message, customer does not contain a constructor that takes 0 arguments. Okay, so now let's say we want to provide that capability. Somebody should be able to create a customer object without passing in any parameters to the constructor. So how do you do that? Okay, you can actually write a constructor which does not take any arguments, something like this, public customer. And then what you can basically do is when you call this customer, when somebody calls that constructor, I want basically I want basically the constructor which takes two parameters to be called, but then I'm going to initialize them to their defaults, like, you know, um, no first name provided. And similarly, for the last name, we will say no last name provided. Okay, so what we are doing here is basically, okay, if somebody calls this default, if somebody wants to create a customer object without passing in parameters, that's fine. They can do that like this, okay? Customer C1 is equal to new customer. Now, when this, if you right click on that and when you say go to definition, it comes to this constructor. But if you look at this constructor, it's calling this customer. This constructor, this refers to this instance of the class. So this here refers to this particular constructor and passing in no first name provided for first name and no last name provided for last name properties, and these are then used to initialize these class fields. So obviously now if somebody is creating a customer object like this, and if we go ahead and run that, look at that, no first name provided is their first name, no last name provided is their last name. Okay, so if you want to make that default parameter less constructor a little more useful, and if you want to make sure that your class fields are initialized to something before somebody calls methods and do something with that class, then you can provide an implementation for that parameter less constructor and invoke any of the parametered construct any of the constructors with parameters to initialize your class fields the way you want them. Okay, but on the other hand, you know if somebody else wants to create another customer object, they can do customer C2 is equal to new customer. And now look at this, there are two constructors now. One constructor which does not, if you look at this, one of two constructors, one constructor, if you look on the right side, no parameters. Okay, parameter less constructor, there is no need to pass parameters. I can do that. Or there is another constructor which takes first name and last name. So there are two constructors with the same name, differing by just the number of parameters. So this is called as overloading constructors. So this class has two constructors, one which does not take parameters at all, another one which takes two parameters. Okay, basically we can overload a constructor, on the number and type of parameters. Okay, say for example P is my first name and maybe T is my last name, and if I say C2 dot print full name, so for the second customer it will say PT. P is their first name, T is their last name. So that's it. Let's go back to the slides. So purpose of a class constructor. The purpose of a class constructor is to initialize your class fields. A class constructor is automatically called when an instance of a class is created. Constructors do not have written values and always have the same name as that of your class. Yeah, that's one important difference to keep between a constructor and a class. Constructor and methods. Methods will have return type, whereas your constructor doesn't have any return type, and they have the same name as that of your class. Constructors are not mandatory. If we do not provide a constructor, a default parameter less constructor is automatically provided by .NET Framework. But once we provide an implementation of a constructor, the default parameter less constructor provided by .NET Framework is taken away. And constructors can be overloaded by the number and type of parameters, and we have seen an example of that as well. So what are destructors? Destructors have the same name as that of your class with a tilde symbol in front of them. They don't take any parameters and they don't have return values as well. Destructors are places where you put code to release any resources your class was holding on to during its lifetime. We will actually talk about destructors and the process of garbage collection in a later session. That's it for today. Thank you for listening. Have a great day.